Okay, this podcast is going to talk about the TCP/IP protocol suite and the OSI model and the differences between them and why I care more about the TCP/IP protocol suite than I do about the OSI model. To get started, let's talk about the difference between a model and a protocol. A model from this ISO document says the basic reference model serves as a framework for the definition of services and protocols which fit within the boundaries established by the reference model. And then it goes on to say the reference model does not specify services and protocols. It is neither an implementation specification for systems, nor a basis for appraising the conformance of implementations. And then a protocol says defines the format of messages and actions to be taken in response of the message. So that's a lot of words. What that means to me is that a model is not real. It tells you how things should be done when you write your actual protocol. And a protocol is actually the real thing that tells how things should work. So if I was to spend my time learning about something and had to pick between learning about a model or a protocol, I would pick to learn about the protocol, because the protocol is what you will be troubleshooting and implementing in industry when you're trying to figure out why things aren't working. You're going to want to know how TCP protocol actually works, and the reference model is not going to help you with that. The reference model idea was that it would be useful for people who are writing protocols to use that. So for example, the OSI model says the transport layer function the transport layer is responsible for establishment and release of transport connections. It doesn't tell how to do that. It doesn't tell when to do that. It just says you should do that. If we look at the actual protocol, it says the three-way handshake is a procedure used to establish a connection. This procedure normally is initiated by one TCP and responded to by another TCP. And then it goes on in great detail to tell you how the actual process occurs, what you should expect to receive, what you should send if you need to establish a connection, how to terminate the connection, and all that other detailed stuff that you need to know to make it work. We're going to learn about TCP. Here's the history of TCP/IP protocol suites. These are the suites that are running the internet today. You probably won't run into much other. In the 80s and 90s, there were some other protocols you run into like IPX and SNA. But for the most part, everything's TCP/IP now. It's a suite of protocols running the internet. It was developed by ARPANET, for ARPANET by the Department of Defense in the mid-70s to the early 80s. TCP was initially described in a paper by Cerf and Khan in 1974. The RFCs that formalized the protocols were published in the early 80s, around 1981. And the first real implementation of TCP/IP was in 1983. BSD 4.2 implemented TCP/IP sockets and many of the other network utilities that we use today, still, some of them. So if we look at the history, OSI was the model was developed between 77 and 84. The protocols for TCP/IP were being developed in the 60s and 70s and actually published in the 80s. So I'm not exactly sure why we're so hung up on the OSI model and talking about the thing that's not even real. I don't really like talking about the OSI model. So for this class, we will be talking about TCP/IP protocols, and we probably won't reference the OSI model very often. You still need to know the layers of the OSI model, because that's just something everybody's going to ask you at every job interview. But I would encourage you to go ahead and say, well, here are the layers, but I don't really like talking about it because it's not real. So let's talk about layers. We have this layered architecture with TCP/IP where we have the application layer, the transport layer, the network layer, the data link layer, and the physical layer. So each layer relies upon the layer below it to provide services to it. So if we look at this diagram, the application layer will pass its stuff down to the transport layer. The transport layer will encapsulate that data inside a transport layer header, pass that down to the network layer. The network layer will encapsulate that inside a network layer header, and so on until we get down to the physical layer where it's actually transmitted. Some benefits of a layered architecture: you have modular design. What that means is every programmer writing an application does not have to figure out how to make network communication work. The programmer does not have to figure out how to establish a session with another host. All that stuff is handled by the lower layers of the TCP/IP protocol suite, which is including the operating system. So all the developer has to worry about is writing his code to do what his application wants to do. Standard interfaces, that means that if I write an application on one Unix box, I should be able to put that on a different Unix distribution, and it should work the same way. So what that means is TCP on every implementation expects to receive the same data from the application, and IP on every implementation will expect to receive the same data from the transport layer, so that you don't have to rewrite your code to go from one Unix box to another Unix box. It should work fairly simply. And finally, vendor interoperability. In the olden days, IBM stuff would only work with IBM stuff, and that's not real good for growing a internet. So one of the goals of the layered architecture is for vendor interoperability, so that everybody can talk to everybody without having to have gateways to translate between the different network types. So we look at the layers of the two, the model versus the actual protocol suite. The OSI model, we have the 7 layers on the left. The TCP/IP, most of the upper 3 layer functions are handled by the application layer. Some session layer concepts are handled in the transport layer, such as session establishment and termination. And then we have the bottom 4 layers are essentially the same: transport layer, network layer, data link layer, and physical layer. I have an unofficial layer I like to call the power layer, layer 0. I will mock you if you forget to turn your router on. It happens every semester. Somebody's like, hey, my console is not working. Hey, you know what? You forgot the power layer. Turn your router on. So let's talk about each layer, what each layer is supposed to do, and who it provides services to, and who it uses services from. The application layer provides services to the user. So essentially that's you sitting at your web browser or you using your email client. It can also provide services to other applications. For example, your DNS client will resolve names for your web browser, and the application layer will request services from the transport layer. It will use TCP to fetch a web page, and it will use UDP to resolve names. The transport layer will provide services to the application layer. So it'll take the application layer's request to connect to a web page. It'll put some session-related stuff on it, and then it'll pass it down to the network layer, and it will ask the network layer to deliver that packet to the end system, and the network layer will use the IP protocol if we're doing IPv4, or IPv6, we're doing IPv6, to deliver that to the end system. The network layer provides services to the transport layer, and it will request services from the data link layer. That the network layer is worried about end-to-end delivery. It's like, I need this packet to make it to that server on the internet. So it will ask the data link layer to take care of delivering that. The data link layer is worried about local delivery. It's worried about getting it to the next hop. So it'll take the IP datagram and it will put a network, a layer 2, put it inside a layer 2 frame, and then it will determine where it needs to be sent to and send it to the next hop along the way. And we'll talk more about that in future modules. The network layer will use the physical layer. I screwed that up. That should say data link layer. No, that's right. The data link layer will provide services to the network layer, and it will request services from the physical layer. It doesn't really request services because the physical layer doesn't really do encapsulation or anything. It just sends the bits. So the data link layer will pass it down to the physical layer, send the bits out the network interface card. Physical layer, that's all the cables, network cards, and that type of stuff. So let's put it all together. Let's get an example we'll be used to. We're going to simplify it a little bit. But say you are sitting at your desk using your browser, which I've called an HTTP client, because HTTP is the protocol used to fetch web pages, and we have this idea of client and server. So your HTTP client is going to put a request, build a request for a web page. It will use the HTTP protocol, following the rules established by the HTTP protocol that the server will understand and it will pass that down to TCP. TCP will take that HTTP client request and encapsulate that request inside a TCP header and pass that down to IP protocol. The IP protocol will take that TCP header, put that inside the IP data packet, put the IP header on it, and pass it down to the data link layer, which in most cases on our local area networks, that'll be sent via Ethernet over our Cat5 or Cat6 cables. There'll be some number, usually, of hops in the middle here that we're going to ignore for now. And eventually the frame will arrive at the destination host or the HTTP server. It'll come in the network interface card and get passed up to the data link layer. It'll strip off the Ethernet header and trailer, take out the the network layer data, pass that up to the IP protocol. The IP protocol will strip out the TCP data, get rid of the IP header, drop that, pass the TCP data up to the TCP protocol. The TCP protocol will strip out the HTTP data, the application data, and pass that back up to the application, which is the HTTP server. That HTTP server will process that request in accordance with the HTTP protocol, and then it will take some action, whatever the client requested, which in many cases is to send back a web page. So then the process happens in reverse. That HTTP server will build the data it wants sent, and it will ask TCP to send it back down the stack across the network and up the other side. We're going to go into great detail about how all these protocols work later on in the semester. So this is just an overview of how things work, so don't stress too much about the specifics of any layer at this point. Some things to consider. That example simplified things a lot. Each layer does some level of error checking. We didn't talk about TCP requires session establishment before data can be sent. We didn't say anything about that. We just said, oh, TCP sends the data. Yeah, well, first we have to do the three-way handshake and that kind of stuff. And then we didn't talk much about addressing information, IPs, MAC addresses, and that kind of stuff. Those are some details we'll get into later. You might be wondering right now, okay, so we talked about TCP and UDP and these different transport layer protocols. Will I ever have to decide which transport layer should be used? And the answer to that is no, or probably not. Unless you become a programmer that creates a new application, then you will not have to decide which protocol should be used. All protocols we use now that are currently existing were designed by somebody who decided what transport layer protocol it should use, and you just have to know which one that is when you're troubleshooting, so you can know what you should be expected to see. So the course learning outcome we covered in this podcast was to relate TCP/IP protocols to OSI model layers. We should be able to do that. You should also, before the end of this course, be able to identify which TCP/IP layer a certain artifact is associated with. So for example, if I say which TCP/IP layer is IP associated with, you should be able to say, oh, that's the network layer. And there's a RFC 1180 that is a very good TCP/IP tutorial. It's a lot of depth, a lot of detail, and it pretty much goes through everything, almost everything we're going to cover in this class, quite honestly. So you might want to read that if you're bored.